Let me now introduce the next speaker, Professor Peter Hovmand, who is a world-acclaimed leader in participatory model building to understand and manage hard problems involving social systems. Professor Hovmand is currently the Pamela B. Davis Professor of Medicine, Center for Community Health Integration at Case Western Reserve University. Prior to that, he has held various key positions at Washington University, St. Louis. He has authored a brilliant book titled Community-Based System Dynamics. Professor Hovmand is also an associate editor of the premier journal in our field, System Dynamics Review. Like Professor Sturman, Professor Hovmand is a longtime consultant and friend of Singapore, NUS, and RC4. Very importantly, Professor Hovmand's work has impacted teaching and research practices at RC4. We are privileged to hear him this morning on a very important topic, how our tools and methods can thrive in a world that is influenced by rapid advances in artificial intelligence. On your behalf, let me welcome Professor Hovmand to deliver his talk. Professor Hovmand.
Well, thank you. And it's truly a pleasure to be able to join with you today and celebrate the 10th anniversary of RC4. And I very much appreciate Professor Sturman's talk, which has a wonderful segue into some of the topics I'll be covering, particularly how we engage communities and participants, leaders, who might often be excluded from the process of building models. So let me start first by just, it was fun getting ready for today's talk, looking through the various pictures of group model building workshops. And I was very happy to see the one on the top left is an RC4 faculty, some students also thinking about the future of system dynamics and as an introduction to a group model building workshop. The one on the bottom is a conference. It's also in Singapore, introducing community-based system dynamics, looking at the topic of family violence at a national conference. And then the one on the right is most recently earlier this year, where through Duke NUS, John Ansa, David Match, and myself led a 2-week introduction to system dynamics with both an introduction and an advanced track that, in my mind, has really reshaped how we think about teaching system dynamics here in Cleveland, Ohio. And there are many, many other examples I could share, but it's been really fantastic over the years. And the other thing I would say is I've often been so impressed by the students I've had the chance to meet when visiting RC4, showing them models and then talking with faculty and the various techniques you're using for introducing system dynamics. So what I'll do today is I was asked to talk about group model building overall as a topic. I'll share a little bit about the context of group model building and why we do it. What is it we're trying to do, and then the different streams of group model building research, and then focus on a little bit more specifically on community-based system dynamics and what distinguishes community-based system dynamics from other approaches, and specifically as it's emerging in applications around addressing responsible AI machine learning, and then close with some thoughts. And I'll happy to share my slides as well. So just to sort of set the stage, a lot of this will be familiar, but when we're thinking about systems, I mean, the challenge here is really seeing systems and understanding, being able to draw inferences that are valid. So John showed some really nice examples of things we sort of get wrong, and then how models can help us do that. And we see different facets. Now, there are different ways we could understand systems. Certainly, many communities use, and we use metaphors all the time. There's the iceberg metaphor in systems thinking. There's the onion model that's often a metaphor for thinking about sociological systems. Lakes, bathtub metaphor for thinking about accumulations. And there are lots of situations where we've been using metaphors, particularly in traditional ecological knowledge or indigenous systems of knowing, where folks are still connected to land and nature, ways that we may otherwise have been separated. We also use maps, a little bit more formal structures. So looking at the disparities of life expectancy in the United States as a spatial distribution. And then an example of the foresight map of obesity, a fairly busy diagram. One that I recall a policymaker from UK who was then at London School of Economics came and gave a talk, and in the middle of a slide said, "Do not share this with policymakers. This is just going to raise anxiety." So John gave some good reasons why we don't want to share maps like that, but they have a lot of information about them. And then we have a need for sort of more formal tools, models specifically, and they include statistical models, spatial models, network models, and then computational models, including agent-based modeling and system dynamics. And a lot of the work that I do is in public health and sponsored by and in both CDC and National Institutes of Health in the United States. And I think it's important to emphasize that there are a lot of, in terms of modeling, that it goes beyond just system dynamics. The multi-level modeling and spatial models looking at GIS, for example, have been recognized as tools of system science, but they have also been around longer. And then the more recent increase in public health has been around the system dynamics modeling, agent-based modeling. Now we gain insights from these models. John gave a nice example of riding a bike and not necessarily using a system dynamics model to figure that out. And there are different levels of system insights, from surface insights, simply awareness that there's a system, to components of the system. And as we work our way down to thinking about what would it mean to transform a system, actually being able to see the potential leverage points, identifying generic structures, being able to understand which systems can actually generate the hypothesized dynamics, figuring out what those leverage points. John gave some excellent examples of finding some leverage points on climate change. And then really being able to sort of understand how the system generates behavior. So these get sort of more rigorous and deeper as we go down. Now, there are different ways, again, we can use the tools. So if my goal is to help raise awareness that we're in a system, a picture or metaphor may be sufficient. But if I want to understand some of the insights at the deeper level, then I'll need something a little bit more formal, like a spatial map or network diagram or causal maps. And then for these deeper insights, we have tools like from statistics, like structural equation modeling, multi-level statistical models, and the computational models that's of interest in particular to system dynamics. The point here is that if what the main insight is that's coming out of the modeling effort is awareness of system or simply awareness of the components, then pictures and metaphors might be sufficient. But for some of these deeper insights, we really do need to take advantage of the tools we have, and particularly the quantitative tools. And then the last one I want to sort of stress here is the role of story, narrative, poetry from lived experience to understand the values that sit with a system. And so we often learn a lot about, at least in the work that I'm doing, as we see causal maps that are being generated by communities, and then people are reacting to them as well as drawing in their own experiences. Often that highlights some of the values and raises questions about why the system is as it's structured. I'm going to focus more on these formal models and specifically system dynamics. Now there's different ways we can do this. For example, this is a spatial map showing the distribution of redlining. The concept of housing and housing risk was a notion that was invented essentially in 1933. And it had built in or created this idea that housing decays, which actually shows up in Forrester's urban dynamics. These patterns here, they persist today in terms of all kinds of outcomes. So one of the things that we see a lot of is people doing more and more studies describing the disparities, but not necessarily talking about how to change the map of redlining. So this would be a structural relationship. Could also look at social networks. This is an interesting paper looking at the strength of weak ties in scientific reporting. So from a social network analysis, we would be looking at different structures, not just sort of describing the social networks or the ties, but actually do the different structures matter? One of my favorite studies that illustrates this is talking about likelihood of getting stroke care that's evidence-based within the first 60 minutes, and trying to understand, do people with stronger ties and family ties do better than others? And it turns out that when folks have more weak ties, in that particular study, they were more likely to get the hospital. There was less negotiation of symptoms. Somebody who's an acquaintance is more likely to say you need to go to the emergency room than a family member. So lots of interesting results from social network analysis. And then, of course, we have agent-based modeling, and this is Thomas Schelling's a version of Thomas Schelling's model of segregation, showing the sensitivity of preferences, trying to explain racial segregation in the United States. And then of interest to me, and in particular, a lot of the work and the students in systems thinking faculty is the role of feedback loops. This is a model by Jay Anderson of the Strategy of Commons. It's one that Ellen Ostrom was aware of early on in her work at a pre-pivotal stage, and her reaction to the Strategy of Commons really led to her focus of study of institutions and informal institutional arrangements for managing common pool resources that led to the Nobel Prize. So I'm going to focus more on the feedback loops and system dynamics specifically, but the main point I want to sort of stress here is these are complementary tools. Each one has a different facet of the system, and all social systems are spatially located. We're tied in social networks. We have actors and rules that are embedded with institutions in the feedback loops. So if you ask me, could we answer a certain question from a system dynamics perspective, I'm going to be looking for feedback loops and dynamics. If you ask a colleague who's doing network analysis, they'd be framing the question from a social network analysis perspective and also be able to answer questions in different ways. The only way we get a more complete picture is actually by comparing our results and working across different disciplines and methods. Now, in all of this, when we talk about structure determining behavior, one of the important questions that comes up in system dynamics specifically, and it's always been recognized, is the importance of engaging stakeholders in the process itself. This goes back to the very beginnings of system dynamics, techniques such as direct observation, ethnography, key informant interviews, focus groups, workshops. In the mid-90s, we started to see an emergence of techniques called group model building. Barry Richmond talked about the strategic forms. And in particular, we have sort of two traditions emerging in parallel. There's the Albany tradition led by George Richardson and David Anderson, and then the Nijmegen tradition led by Jack Venitz and Etienne Rouet. They differ. So when George would often draw the contrast with the Nijmegen tradition, George and David would emphasize the use of group model building as the intention of actually going ahead and building a formal simulation model, versus the version versus group model building in the Nijmegen tradition is broader. Not everything goes into simulation model. If it solves the problem with a qualitative map, that is sufficient. In that context, it's worth also thinking about why we would want to do group model building in general. So some of the reasons over the years that I've thought about it and picked up are, well, we're eliciting information about the structure of the system. This is a picture of a workshop in Singapore where the focus is led by myself along with David Matcher and John Ansa. And the goal here is to work with a group of healthcare providers, policymakers to think about enhanced primary care in the context of Singapore and switching of incentives within the healthcare system. There have been more recent presentations of later stages of this work as some of these policies are actually being discussed and I believe implemented at this stage. But eliciting information about the structure of the system is one goal. Another is seeing the system together. So earlier, those questions were coming up. Well, not everybody's a systems thinker, and that's true. I think there's sort of people tend to see the systems thinker, because we're not selecting for systems thinkers in education, tend to be randomly distributed. And I certainly have had experiences in workshops where there's somebody who really is seeing the system because in a more holistic way and able to advocate for policy. But even in that scenario, the challenge for the systems thinker is often how to convey or persuade others to see the system in a similar way, especially if the insights are counterintuitive. So seeing the system together becomes one of the reasons we might want to build a model collectively. Also sharing the system insights. I mentioned they were counterintuitive. One of the early workshops I did, I had a participant who talked about a concept of dignity of risk. This was a statewide mental health transformation project, and about 200 people involved. There were 5 working groups, about 50 people each. They met every other week, and the initial kickoff meeting had a series of group model building workshops where we're doing some causal mapping, and one of the groups was the consumers and family members. And the way this was set up in terms of as a contract was basically if it didn't pass the consumer and family members work group, that was the end of the work, which set a pretty clear expectation. One of the participants who was a consumer and family member came up and later talked about this was the first time he really had a way of having others and seeing how others could start to understand some of the complexity he had to deal with day to day as a consumer of mental health services. And one of the concepts he brought up was this idea of dignity of risk, which is, from his perspective, was he was going to benefit or lose as a stakeholder in that policy transformation, and so at least give him the dignity of risk to be at the table. So a lot of the work that I've done, it really sort of builds on this notion, which is basically very quickly we started when I was at Washington University Social System Design Lab, working with the assumption, let's not assume that people can't learn or it's too technical. Let's assume it's more of a methodological problem and then figure out how we teach it and introduce the methods. And that was the edge we always sort of worked on and continue to do so. And the last one is group model building as intervention. And that could be a number of different, the goal there could vary. There's certainly practices where people are using group model building as a way of forming consensus. But you could also see group model building as a way that sometimes you have people are stuck in their thinking, they're stuck in a particular paradigm, and the models that are being generated function as a generative metaphor, to draw on Donald Schoen's term, and this helps them reframe the problem from a different perspective. Now, a little bit more specifically about community-based system dynamics. So the work that I've been most involved with really begins sort of building up group model building and thinking about the problem of how do you engage communities and participants, and thinking about community here initially in the context of a neighborhood in some of our childhood obesity work, or thinking about a village that we're working with in India through Foundation for Ecological Security, or a school system like Rittner School District in St. Louis. And a lot of these approaches, they drew on group model building, both in the Albany and Nijmegen tradition. We had 2009, a strong collaboration with Albany and working with David and George to develop scripts. And then around Chris Dave had a fairly significant influence. She uses the term participatory systems modeling in part as a reaction not to confuse what she's doing in terms of the causal mapping with the group model building in the Albany tradition. But one of Chris's points is that she would talk about her work on air quality in Las Vegas, and she would describe how she would have some workshops where there was somebody who was a skeptic, and then later on they would turn up in another workshop and they would actually be the champion for using system dynamics and moving into simulation model. And that actually became a pretty important insight, sort of recognizing that it's not just isolated projects, but these projects are happening within a community context. And we could think about that within an organization, within a region, or a much broader community. And so there's an opportunity to learn across time and projects, engagements. And a lot of what I've seen over the years really builds on that. And Singapore is one of the hubs of communities of practice in terms of thinking about system dynamics. And I see lots of examples of that every time I visit. So community-based system dynamics draws on these various traditions, also has a strong theory around social epistemology, how we know things collectively, adult education, sort of addressing some of the challenges of introducing system dynamics and a new set of conventions in a context where there often are power dynamics, there are different levels of literacy, different expectations. Paula Ferry's also written quite a bit about that, and Miles Horton, along with a very specific theory about language and meaning that comes from Wittgenstein, Marilyn Frye, Max Black, Austin, and Fleming, and sociolinguistics. So this is a paper, not written by me, but I think it's actually one of the best summaries of contrasting the group model building, the participatory systems model, and community-based system dynamics. And I'm going to focus more specifically on the community-based system dynamics now. On the right, as you see, some of the work we were doing in West End neighborhood in St. Louis in collaboration with Mount Carmel Baptist Church. These are the participants, and one of the neat things is quite a few of these folks are retired. And this is actually has turned out to be periodically we would check in and ask how we're doing. Is this still rewarding? And we'd have people sort of be very, very enthusiastic about continuing to learn and thinking about childhood obesity in their neighborhood, along with other issues. So to me, the community-based system dynamics, it's an approach to group model building. So it's one of the ways you could do group model building with a focus on engaging communities in system dynamics, and really with the emphasis on building a common language and building capacity over time, and that's really critical. It's not a single project. So when people come and they see a group model building workshop that's following community-based system dynamics, there's stuff going on in the workshop. There may be stuff going on in the project, but the real question is what's happening across time with multiple projects. Do you see models getting better? Do you see more capacity developing? Do you see more community members taking a more active lead in defining the problems, leading the project in collaboration with folks who have more formal training over time? And the example here that I love to share is from some work in, I believe this is Karnataka in India. This was in collaboration with Foundation for Ecological Security. And we would have students go for 2-week stretches, work with students from Indian universities, IIT Bombay, Tata Institute, as well as Foundation for Ecological Security and staff. And they'd be broken into teams, and each team would be working with the village, initially starting to initial engagement and then beginning to sort of conceptualize the system and building simulation models, asking questions. At the end of this 2-week workshop, there'd be a final presentation. What's neat about this picture, which I emphasizes the point here, they're looking at water resources and bore wells. But at this point, no member of the team, FEF staff, students, or the faculty are actually explaining this. The community members introducing the conventions. One of the villagers is using a flashlight to help facilitate. Somebody else is explaining what the different symbols mean and the connections, and they're discussing this. So that capability to read the causal map, interpret it, use it, modify it is now moving into the hands of the village in a fairly short period of time. And that capacity then continues to build and grow is the idea. One of the key ideas here in why this works and how to think about it really draws on picking up an idea, not that from an early paper that had pretty big influence on my learning of system dynamics from David Lane. And what he was looking at was the question of whether system dynamics could have a role in understanding some debates about agency and structure in social theory. He mapped out different practices of system dynamics and essentially argued, so on the horizontal axis, you have different paradigms of social science, and on the vertical axis, you have different paradigms of social change. And he essentially argued that system dynamics actually was sort of agnostic with respect to the paradigm. So one part of that's very helpful is for me as I was learning system dynamics, is as understanding as I'm reading different works, people actually have different philosophical assumptions. There's a method overall, but that there are different approaches to thinking about some of these questions. But the more interesting piece for me was, well, that means you could essentially learn a method and begin to learn the practices, and then you could sort of move across these different paradigms depending on the problem and how it worked. Now, others would argue that you should learn different methods for different practices. So SD might be more appropriate down here, systems thinking might be broader, critical systems, and this sort of generally fits in a critical systems approach. But if you're trying to build capacity in a community context over time through multiple projects, then it becomes important that there's some building of that knowledge over time. And then I think when folks get sort of too broad of a view. They don't necessarily get any sort of depth in a particular approach. I think it becomes quite challenging to actually apply any one method effectively. And so having some experience over time becomes important. And one of the ways of doing that is to learn a set of methods and then how to apply them to different types of problems. And so that was conceptualized in community-based system dynamics as learning problems, coordination problems, transformation problems, and analysis problems, where there would be there's some sort of triaging where we're at, and then there's some progression. So a lot of the work I do when I'm engaging communities, for example, starts with a learning problem, and then over time through one or more projects would become a coordination problem, and then there'd be some sort of consensus and focus and motivation for building the more formal models. So there's an analysis, and then it would move into transformation models. Others have looked at the same sort of framework and said their cycle works slightly differently depending on what field they're in. So David Ford would talk about his work often starts with an analysis problem, civil engineering becomes a transformation problem, then a learning problem, coordination problem. Just to illustrate this with a recent project involved with some work, this is led out of the University of Hawaii, Manoa, and it's focused on children's healthy living and food systems across the U.S. affiliated Pacific. So it's a huge region going from Alaska to Hawaii, American Samoa, Guam, and Northern Mariana Islands. All are being severely impacted by climate change and disruption in food systems. John talked about COVID. This has been a major issue. In this particular project, the goal is to understand the community context that underlies a randomized clinical control trial of food systems intervention, and it fits into the larger context of work. But to do that with this team, we started with a series of models. These would be sort of teaching or learning models initially, and then we did some initial group model building workshops, and then we're evolving these. So we have one version that's a causal loop diagram that's more conceptual in nature, and then now building a research model. The point here is that these are multiple projects or smaller projects, engagements, and they evolve over time, and that's one of the ways we build this sort of larger capacity in community-based system dynamics. So my favorite example I'd love to share is John was talking about K-12 education. When I was in St. Louis, we had a program called Changing Systems, and we had been engaged with high schools for some time through the work of Mary Sheets at Rittner School District. After Ferguson in 2014, the high schools in the region pulled together. There were 19 public high schools, and they had a series of exchanges and summits, and they wanted something that was culminating experience, and asked if we could host a summit for high school students focused on racism. So we did that, and that the focus was 2015. That initially had things like hopes and fears, graphs over time, connection circles, no simulation modeling. Next year, they wanted to focus on gun violence. So again, sort of more experience, quite a few returns. Some graduated, they became program assistants. Next year, they wanted to focus on youth homelessness. They were sort of at that point, some got tired. They knew they could build simulation models. Now some of them wanted to see a little bit more. They wanted introduction to shocks and flows. 2018, that continues to grow. By 2019, there's some that are really now have had several years of exposure building simulation models and getting some exposure, but they all want to see it. They basically don't want to be left behind. They're not interested in being modelers, but they want to know what their peers are doing. And they are using the model to think through the stocks and flows of stress and emotional support in school, and use that to essentially effectively advocate for policy changes, many of which were actually pretty easy to implement. So this is what I'm sort of looking for when I'm thinking about community-based system dynamics. I'm looking for multiple projects and topics within a community context, and the depth of skills and the continuation of those skills growing. Here's just an example of a causal map that was generated from the work. Now I'm going to shift a little bit to talking about the applications in more recent work that's focused on AI and machine learning. This work really sort of begins with an introduction to community-based system dynamics at Data for Black Lives conference. It was at MIT in 2019. Where CBSD was introduced and used as a way of eliciting causal knowledge. Donald Martin at Google Research has been leading an initiative responsible AI at Google Research, and essentially has a number of examples, but shares one in particular about the impact of bias in AI impacting healthcare and healthcare decision making. Rua Benjamin was also at that Data for Black Lives and had some exposure through that conference, and refers in her work on race after technology to system dynamics and community-based system dynamics as potentially one of the ways that we could engage communities to address some of the biases that are baked into the training data sets in AI/ML. She just won the 2024 MacArthur Fellow, and sometimes referred to the Genius Award. So let me talk a little bit about that. So this is an example of how, so early on the work that Donald Ellis and Irene and Jill Krollberg, all colleagues, were thinking about the role of bias appearing in AI/ML. One thing I'll note here is that this idea is not a new, thinking about sort of the need for having more contextual information. Forrester in a 1980 paper talking about information sources talks about the numeric database, the written database, which is what's often accessible in training data sets, in contrast to the mental database from an observation experience. So Forrester was certainly familiar with this idea of the richness of information we carry around in a societal context. There are also other works by Elaine Tesorius and Jason Jaron Lanier, for example. Jaron was a Microsoft engineer, did a lot of work, but became quite concerned about the way data was shaping algorithms and ownership and the extractivism that he was seeing on the horizon. So people have been talking about this for a while, and the question is whether this sort of thick data for representing contextual societal knowledge can help, or if there's a role. So I'm going to paint a picture here of how I'm viewing this. This is always a little bit risky because it's not a specific argument that somebody's making that I'm critiquing, but it's something I've run into a number of times as folks from various big tech industries have talked to me about using causal loop diagrams and the role of CBSD in particular. So the view here is that we have data, numbers, images, text that are being used to train AI/ML models. That data lacks societal context, and so it's not understanding certain dimensions, and that leads to biased outputs. There's a demand then for some sort of thick data that can represent societal context. And if you do a Google search, and this is exactly what people are doing, they're doing a Google search for things like causal loop diagrams, and you can get a pretty extensive list. And then there's an association that CBSD through group model building scripts is one way you can engage community in a participatory way for generating these causal maps. And so the picture is something along the following lines, that you would have CBSD generating this context, and then that can be used to address some of the bias. Now, this view is flawed for several reasons. And probably the greatest source of that is sort of misunderstanding some of the social epistemology that underlies community-based system dynamics that's not explicit or apparent in I think the earlier forms of group model building. A better view is thinking of this as a form of thin description. John Jackson in particular is an ethnographer and describes and illustrates thin description. Rua Benjamin in Race After Technology cites Jackson's work, and her own text is described as a form of thin description. There are two key ideas around thin description, and this is in contrast to the notion of thick description in ethnography. The idea of thick description and the illustration is the person winks and all the interpretation that could be extracted from that single wink. Thin description is the opposite, and sort of really recognizes that these descriptions are just slices, and then importantly that communities have and retain the interpretive resources of the system. So let me share a little bit of some work that we're doing presently that's along these lines and what that might look like, and then close with some thoughts. So we're doing some work. This is supported by a Google gift. This is in collaboration with Morehouse School of Medicine, as well as my colleagues at Case Western Reserve. And the specific goal here is to essentially use community-based system dynamics and develop models that help us better understand cardiovascular health disparities in the United States. And in this specific context is the Atlanta metro area. Here you see participants who have been recruited from a prior study, the MIDAS study that was led by Morehouse in collaboration with Emory University for reducing cardiovascular health disparities. And the question they're being asked here is around the concepts of cardiovascular risk and in response to the prior research. Participants are very quickly picking this up and getting engaged. And then in part of that comes out a model. You can explore this yourself, but this is one I frequently use to introduce the idea of leverage points, talk about sort of a general characteristic about green space and physical activity. And very quickly, we're sort of moving from a picture where people just want to sort of be involved in the causal mapping, or they want to share the approach in their church to help others understand cardiovascular. And there are some that now really want to be much more involved in actually building the simulation model. So this is now spread. We've looked at cardiovascular risk that continues. There's work on long COVID. And then most recently, utilization of smartwatches for monitoring stroke risk. And this work is continuing to grow in out of Morehouse School of Medicine. So this is one example, and the larger context here is using this to help inform better design of AI ML for screening that in work that Morehouse is leading through the AIM Ahead. Second example that I really enjoy and continue to collaborate with is work with Undivided Cleveland. This is a community-based organization that's specifically trying to dread lead poisoning. There's a video from after the first workshop at our Think Box on Makerspace. And the key point here is that this particular project is both actively illustrating sort of the design of the workshop and its conceptualization of how they're thinking about ripple effect of action. So these are terms that they're used. This is the causal map that resulted from the initial group model building workshop. And now we have simulation modeling data that's being collected. It's primarily framed as an environmental justice project using implementation science. But the other component here of the thin description is the way Undivided in particular is retaining the interpretive resources and control over how these images are being represented. And I'm happy to expand on that, but this work continues. And let me just finish with a couple of closing thoughts now. I think there are many potential uses of system dynamics for addressing the bias in AI ML that should be explored and developed. I think the main issues that I'm seeing where there's some limitations is when people assume that the causal maps that are appearing that are available, they're equivalent to societal contextual knowledge. So there's a tendency of folks to see the causal maps, assume that they represent a community's perspective and want to use them as a substitute. And then part of the tension there often ends up being when I talk about that's not really what these are. And part of the reason here is communities are what people choose to share when they're in their workshop, especially when they're learning something new, is not going to be everything. It's going to be provisional. It's going to be strategic. It's going to be something that's probably never going to start to feel, you could say authentic is the wrong word, but it's not going to have the sort of vivacity or the clarity until it's really co-facilitated or led by somebody from their particular community. And even at that point, you'll see that people that the interpretation of the diagram is tied to the participants having their own ability to map their story. So an example of this would be the really best causal maps are ones where, like in the West End, for example, that I mentioned on childhood obesity work, a community member comes in and sees the map and recognizes the language in one part of the diagram. And we had one high school student, for example, say, "Oh, I remember when that was happening." Then reads back that particular piece of structure, figures out the convention, and then can read the rest of the diagram. That doesn't mean they necessarily know the simulation modeling, they're all the interpretations, but they're leveraging their own interpretive resources, understanding the context to understand that diagram. So the understanding of that diagram doesn't live somehow. It's difficult to sort of just separate the diagram from that contextual knowledge. The other piece here that I want to sort of close on, and I think this is one of the reasons I'm so excited about the work of RC4 in particular, is that this interest in the causal mapping is continuing to grow, and it seems to be growing exponentially faster than it has been before, and there are more tools that are available for doing that. But what worries me is at the same time we do have many tools actually for building these models and developing these deeper insights and gaining insights to structure behavior relationships that we haven't had before. There are tools like loops that matter in Stella, for example, that not perfect, but they help somebody who's new in system dynamics to see that structure behavior relationship in a way that might take somebody many years or a lot of mathematics to understand, and so that could be made much more intuitive. My general feeling is that we have at this point tools to build these models and build them faster than we've in ways that we haven't been able to do before to represent. John showed some excellent examples of spatial representations. That's fantastic. That really makes a difference in how people interpret impact. It's also why we need RC4 more than ever before. I think the exposure to simulation modeling and the examples I've seen from students before is really just the beginning for helping us sort of understand the value of not just the mapping, but the simulation models. So I'll close here. I know we're running a little bit late, but we should be able to also take some time for questions.